Okay, let's do another example for the second derivative test. A function is given and we are trying to find its relative extrema using the second derivative test. The function is e to the power 2x cubed minus 3x squared. So as you know, these steps for the second derivatives that find critical points first. Um, Well, in this case, it means that we'll find f prime, which is, well, e to the power something. The derivative is the derivative of that something, e to the power the same function up there. So this is 6x squared minus 6x times e to the power 2x cubed minus 3x squared. Set it equal to 0, this means that, well, either e to the power 2x cubed minus 3x squared is equal to 0, but this is not possible because e to the power of a number is always positive, it cannot be 0. But the other part is 6x squared minus 6s, x is equal to 0, and that means that we have 6x times x minus 1 equals to 0, and that gives us 2 point x equal to 0 and x equal to 1. Okay, the second derivative now, the test, to be able to apply it, we need to find the second derivative and evaluate f double prime at the given point, at the above points. Okay, so means that I have to differentiate f prime another time. But as you can see, this is product of two functions. So we need to do the derivative of first one times the second one plus the first one itself times the derivative of the second one. Okay, so this gives me 12x minus 6 e to the power 2x cubed minus 3x squared plus 6x squared minus 6x. And you see that the derivative of this guy is same as the derivative of the function, so it will have again this same factor. So this will be squared e to the power 2x cubed minus 3x squared. Then let's factor e to the power this piece, 12x minus 6 plus 6x squared minus 6x squared times e to the power 2x cubed minus 2x squared. Now we want to evaluate this function at x equal to 0 and at x equal to 1. Very nice. So at x equal to 0, f double prime at 0 is 12 times 0 minus 6 plus 6 times 0 squared minus 6 times 0 squared e to the power 2 0 cubed minus 2 times so this is 3 times 3 times 0 squared. Yes, well, this gives us, this part is e to the power 0, this is 0, this is 0, this is 0, so it will be minus 6 e to the power 0, which is minus 6. It's a negative number. If f double prime is negative, the second derivative test says that f at 0 is a relative max for. And let's do the other one, f at 1, so 12 times 1 minus 6 plus 6 times 1 squared minus 6 times 1 squared times e to the power 2, 1 cubed minus 3, 1 squared. This is f double prime at 1. And what we get here is, this is 6 minus 6, this piece is 0. This is 12 minus 6 is 6 e to the power 2 minus 3. So it is 6 e to the power negative 1, which is the same thing as, don't let that negative 1 in the power confuse you. It will be 6 over e. E is positive number, 6 is positive number, so this is positive. As a result, f the value of f double prime at 1 is positive, so f at 1 is a relative mean for f. So this way we were able to evaluate and find those values. By the way, this is nice, that the function is nice, so we can actually evaluate what is f of 0. It is e to the power 0, which is 1. So 1 is a relative max. And here if it is 1, so f at 1 is e to the power 2 minus 3, which is 1 over e, is a relative mean for the function.